introduction for task 1, we mainly focus on the application of the first order differential equation based on data of the population in Belize from 1999 to 2019. And the implementation of task 1 is to find the expected growth of population in Belize by assuming that the rate at which total population in Belize increases at a given time is proportional to the number of population at that time. From the table above, the data was obtained from the total population of Belize by the Data World Bank. Therefore, we can observe from graph the total of population from 1999 to 2019 is increased. For implementation part, we use multiplication model to find the general solution, which is P equals to AE power of KT, which is P is population, T is time, A is the actual value from the data obtained, and K is constant. For example, when T equals to 0, then the population equals to 233,059, and then substitute P and T in formula and we get the value of A, which is the same as P. Next, when T equals to 1, P equals to 2, P equals to 247,099, and then we substitute T, P and the value of A from T equals to 0 to find the value of K, which is 0.0327. Therefore, the particular solution that we obtain is PT equals to 233,059 E power of 0.0327T.
We have plotted a graph of population of Belize in time and years. We plotted two graphs in one diagram, that is the actual population data graph in red and a particular solution graph in purple. The graph begins in the year 1999 where the population was approximately 233,000. As time progresses, the purple graph rises more steeply, indicating a faster growth rate. In contrast, the red graph grows more gradually, reflecting the slower real-world growth. The particular solution graph overestimates population growth compared to the actual data graph, suggesting it may be missing real-world limiting factors such as resource constraint or policy changes. We predict the future record of number of people in Belize in the year 2021. So we set T equals to 22 and substitute it into the equations. Then we get 478,517. Hence, the future number of people in Belize in the year 2021 by solution is 478,517 compared to the actual value, which is 395,346. We also determine that the estimated value is higher than the actual value.
Other than that, we also predict a past record of number of people in Belize by setting T equals to -10. Using the same formula as before, we got the past number of people in Belize in 1989, where solution is 168,055 compared to the actual value, which is 179,107. We also determine the actual value is larger than the estimated value. Next, we continue with analysis. In this analysis, we find the percentage error for both future and past value. We calculate by using the stated formula, which is experimental value minus theoretical value, and then divide again with theoretical value. And then the whole value multiplied with 100. So, after calculate, we got percentage error from future value is 17.38%, while for past value is 6.58%. And this is the table for percentage error from the data we collected.
So for discussion, question 1, are the values calculated from the particular solution accurate with the actual values? So we can observe that there are deviations from the actual values when comparing it to the particular solution. Hence, there are errors, and we believe that there are several factors and reasons that lead to the deviation in this data. Second question, if there is any difference between the actual value and the value calculated from the particular solution, why do you think it is so? So the particular solution is based on an exponential growth as shown by the presence of E, which assumes constant proportional growth. However, real-world population growth can be varied due to changes in birth and death rates, migration patterns, and natural disaster or pandemics. These real-life factors can cause the actual population to deviate from the predicted values.
Third question, what has affected the population growth of Belize in the past? In the past, the population growth of Belize was affected by several things. One of the main reasons was migration. Many people from nearby countries like Honduras moved to Belize to escape problems in their own countries. At the same time, some Belizeans left the country to look for better jobs or education in places like US and UK. Another reason for population growth was more people that are born and dying. Economic changes also played a role. When there were more jobs and better living conditions, more people stayed and moved into Belize. But when the economy was not doing well, some people choose to leave. Next question. What do you think
might affect the population of Belize in future. In the future, population growth in Belize might be affected by similar things. If the country continues to develop and create more jobs, especially in areas like tourism and technology, more people might want to live there. Climate change could also have an impact, as it may impact farming, housing, and health. Also, if education and healthcare improve, people may choose to have smaller families, which could slow down the population growth. Changes in migration and government policies could also shape what happens in the future. As for conclusion for task 1, based on our calculation, the value for future population is 478,517 and past value prediction is 168,055. The difference between actual value and predicted value shows a small percentage error, which is 17.38% for future value and 6.58% for past value. This happens might be due to real-life factors such as migration, mortality and natality rate changes and other external influences.
From the question given, integrate square root 8x cubed cos x plus 3 with the limit of negative 1.320. I will solve the question by using 8 subinterval. From the question, we can determine the value a and b. The value of a is the lower limit, which is negative 1.3, and the value of b is the upper limit, which is 0. From this information, we can find the h with the formula b minus a over n, which n is our subinterval 8. After inserting the value, we get h equal to 0.1625. We formulate the Excel as shown in the picture. We can get the total sum of coefficient time fx. We can also determine the final answer, which is 1.432. To get the final answer by using the formula, we substitute the value of h 0.1625 for the y value. We substitute the first value of coefficient times x, which is 1.505. For the yn value, we substitute the x value of y, which is 0. For the sum of y odd, we substitute all the value from the odd n, while for the sum of the y even, we substitute all the value from the even n. After all, we still get the same final answer, which is 1.432. For plotting the graph, we use Desmos to plot our graph. We enter our equation, the value of upper and lower limit, and also enter the n, that is our subinterval a. As shown, the value of area under the graph is 1.432, which is still the same final value as before.
Lastly, I'll explain about how we solve the same question but use 10 subintervals. First, we find the h by substituting the value of a, b and n into the formula, and we get 0.13 as h. After that, we formulate the Excel as shown in the slide to get the value of total coefficient times fx. We also formulate the Excel to get the final answer, which is 1.43217. For using the formula method, we substitute the values in the Simpson rule formula. As you can see, we substitute the h as 0.13 and y0 is the first value of y, which is 1.505. Then for the yn, we substitute the value of the 10y, which is 0. For the y odd, we substitute the value of y that is obtained from the odd n. And for the y even, we substitute the value of y that is from the even n. Therefore, for the final answer, we get 1.432 since we substitute the values in 4 decimal places. And then, as for the graph, we plot by using Desmos by entering the equation, following by setting the value of upper and lower limit, and also the value of n, which is 10 subintervals. As you can see, the red shadow is the area under the graph, and we got 1.43217 as the answer, which is tally to the Excel method and formula method. So I think that's all from our group. Thank you.